So in this tutorial we're going to optimize a design for a hand pump. In one of the earlier tutorials we looked at sensitivity analyses on this part, and essentially you can regard that as the manual way of trying to optimize a part based on varying dimensions of the part and looking at that, how that affects certain measured properties of the assembly. So we were measuring the volume, we were looking at how the volume was affected when we changed certain dimensions within this assembly. Now optimization allows you to do a similar thing, but the system will vary the dimensions that you give it access to with an eye to a goal, a specific goal. And our goal that we're going to set the system in this optimization is to maximize the volume that the pump can deliver. So we're going to tell it to try and maximize the volume. We're going to allow it to vary some of the dimensions of the model, and we're going to give it maximum and minimum values that it can vary the dimensions between. And then additionally we're going to put in a design constraint as well, and that design constraint will have to do with minimum clearances between parts. So we're basically telling the system that these two parts cannot get closer than, and then putting a figure on that. And what the system will do is, depending on how many increments we give it to vary within its range, it will sit there and calculate all the different variations of this assembly with an eye to maximizing the volume. And when it finds the optimum one, it will change the model for us, or it will give us the option of changing the dimensions of the model, and we can be happy that we have the most optimized design with respect of our goal that we've given it. So we'll if you want to load this assembly in, it's the hand pump assembly, and it's in hand pump optimization. So you can see I've already loaded mine in, and you just want to make sure that you have all the datum options deselected. So I already had mine deselected there. And I think what we'll do first, because we will need access to the features inside some of these parts in the assembly, is we'll go into settings and tree filters, and we'll just allow the display of features to be switched on there. You can see now that we've switched those on, we can browse inside any of the parts or sub-assemblies here. So that will help us later on. What we can also see is there are some measured values here. So these will have been set up by going into the Analysis tab and measuring certain items, distances and volumes and so forth. And they've been made resident in the model tree by saving them out as features. So we have one to do with valve height, we have another one to do with clearance, which I understand is the clearance between the underside of this part here. So this surface on the underside, that surface there, relative to the top of the cylinder. We have a range of motion, which is to do with how far the plunger moves when the handle is moved through its full range of motion. And then we have a volume calculation as well, which will be the cylinder that is described when the plunger moves from its lowermost portion to its uppermost position. Sorry. So all these have been set up already in this assembly for us, but we could set them up ourselves. So what we're going to do first is we're going to define our optimization, and you'll need to select the Analysis tab and the feasibility or optimization button here, and we get this new window. We're going to give our optimization a name, so maybe max vol for max volume would be good. We're going to hit enter, And then we're going to start defining some of the variables in our optimization. So the first one that we're going to change is this. We're going to want to maximize the volume that this pump delivers. So you can see there's those measured and calculated values there, and we can get access to them in this drop down list. So the volume one is right at the bottom there. So we're seeking to maximize that. We're going to add in the constraint to do with the clearances or the minimum clearances between certain parts. So let's add that in now. And it's this clearance figure that we're interested in here. And we're going to make that greater than or equal to, and we can't actually enter anything into this box until we select set there. And we're going to have 0.25 as the minimum clearance between those parts. So you can see that we've entered that. So the next thing that we need to do is tell the system which dimensions we're going to allow it to vary. And the way that we do that is add dimension, and if we select a part in the window here, you can see that its main governing dimensions become visible. So we're going to allow the system to vary the length of the handle. So if we just select the 20 there, that corresponds to the length, and then we're going to allow it to vary the length of this link as well. So we'll click the link, and the length there is that 8 mil currently. So we're going to select that, and you can see that these are appearing in our table there. So the last dimension that we're going to allow the system to vary is the distance between this hole here and this hole here on the handle. But in order to get access to those dimensions, we don't just click the handle. We're going to have to browse within the handle and find that hole there, and it happens to be this hole 153. So if we select that, you can see its distance along the handle becomes visible. So we want to add that as well. So we're nearly there. We've almost defined our optimization now. The only thing really left to do is to just tweak these minimum and maximum values for each dimension that we've selected. So again, all this is listed in the tutorial text, and for the link length, it gives us a minimum of 6 and a maximum of 10. So that would be this one here. So we'll enter those values. The length of the handle is minimum of 18 and maximum of 22. So we're already there with those values. And then the pin distance along the handle, we're going to allow a minimum of 5 and a maximum of 10. So at this point we've defined the optimization, we've defined what we're looking to achieve with the optimization, so that would be the goal. We're looking to achieve a maximum pumped volume. We've put any constraints in there that we don't want the system to violate, so we never want these two components to get closer than 1/4 of a mil together. And then we've told the system what dimensions within the model we're going to allow it to vary, and what ranges we're going to allow it to work between. So we've given it possible maximum values and minimum. So we're pretty much there. We can let the system compute this, and what the system will do is it will vary the model in search of this goal. And you should see the model update in the window here as it computes as well. So we'll just hit compute. So this may take quite a while, because obviously what the system is doing in the background is it's varying these values and rebuilding the model, and maybe doing that lots of times before it finds the optimized version of the model. So here we see the optimization graph, and we can see down at the message portion of the screen at the bottom here, the part was successfully optimized. We can also see, if you just increase the size of that, so you can see the last message that the system gave us, completing step 11. So it's taken it 11 tries to hone in on the optimum size for our dimensions there. So we can shut that graph down, and we can close our optimization, and then we get this message. The model has changed as a result of the optimization. Press confirm to keep the changes, or press reset to restore the original model, or press cancel to return to the design study. So if we were happy with the changes that it had made, you can see just anecdotally here the distance between the two holes in the handle has increased significantly from our original design. So let's say that we were happy with that. We could just hit confirm and it would keep those new dimensions. So we've let the system optimize our design based on changing certain governing dimensions about the part. So that's the end of the design optimization tutorial.